development of the economy of the each and every country. So, basically the nanotechnology helps to leads the economic growth of the nations or country. It enhances national security. Should also that improve the day-to-day life, quality life. Sheets provide a lot of employment opportunities in various industrial, research and academic sectors. Also, it provides the safe and clean environment everywhere. So, in that need of nanotechnology is concerned that it provides a fuel economy. So, that cost of fuel has been reduced. So, ultimately that efficiency of the vehicle has been improved. That means the performance has been improved. So, emission has been reduced. That means that pollution has been reduced. So, that body structures is the weight reduction. So, the structure has changed as with the weight reductions. So, that efficiency automatically will improve. It provides a very small and simple and cost effective. These are the basic need of that nanotechnology. So, that lot of huge manpower requirements in nanotechnology. According to the National Science Foundation, that estimates that in the year of 2020, they need that 2 million workers in the worldwide in the field of nanoscience and technology, as well as 5 million workers needed in support area of nanotechnologies. So, by the 2030, we are expected that nanotechnologies need for a $3 billion in industry. How the nanotechnology has been? Basically, in the year of 1959, the scientist Richard Mannan, it's the idea that there is blend the bottom. It manipulates to individual atoms and molecules. This is a speech is delivered in that Richard Feynman in the year of 1959. After that, in 1974, in the University of Tokyo Science University, Professor Nario Taniguchi is described the machining with tolerance in the nanoscale, in the nano level. So, after that, it is properly coined by Dr. Eric Drexler through his article, The Creation of Nano Engines, in the year of 1986 at Defense Research Laboratory in United States of America. The term refers to that manipulation of water and the nanometer scale. That's Dr. Eric Drexler is properly coined in the article through the creation of nano engines. These are the development of the nanotechnology. So, we know that nanotechnology basically it's a process of creation of useful, it should be useful and functional materials. It may be materials or devices or systems by the control or manipulation of individual atoms and molecules. That is more important. How its material has been developed, nano material has been developed, control on manipulation of individual atoms at molecules at nanometer scale, which is 1 to 100 nanometers. So, nanotechnology basically it's a basic, deals with various things, manipulation of part engineering. So, nanoscience is basically it deals with the structures, physical and chemical properties, which contains the 1 to 100 nanometers. So, it's called the nano structures. It's basically it's focused on this as well as structures. It's application based, where the researchers developed the new materials which has been applied for applications. They developed the new methods for day-to-day. I concern that it's the lot of research going on in nanotechnology in atomic, molecular or macromolecular level, which is the length. The nanoscale is 1 to 100 nanometer range. The technology development also is taken place in the at molecular and macromolecular range, which approximately it's 1 to 100 nanometers. It's create the useful structures, devices, and systems which have the novel properties, the superior properties. So, which helps to the detection of diagnosis of disease and in the COVID. That time it's during the COVID as nanotechnology helps to lot of helps for development of nanomedicines and treatment of COVID-19. So, nanoscale, it's basically we know that nanoscale is a 1 to 100 nanometers range. So, what is 1 nanometer? 1 nanometer is a 1 billionth or it's a 10 power minus 9 meter. This is the 1 nanometers. So, we know that the smoke particles, single smoke particles of cigarette smoke particle. It's 10,000 nanometers. Average width of human hair. So our human hair is approximately 75,000 to 1 lakh nanometers. This is the level of size of nanometers. So we can the Hitchhiker's nanochat, which helps to describe the size of nanometers. See that top in the human is approximately 1.5 to 1.75 meters the human height. So it's gradually decreasing the fly. It's 1 centimeter, and then hair diameter is 75,000 nanometers, or it's 10 power minus 2 meters. So limit of eyes is 10,000 nanometers, or it's 10 power minus 4 meters. So this is called that macro world. Then it's bacteria is 2,000 nanometers, or 10 power minus 5 meters, and its nano shell, it's about 10 power minus 7 meters. These are that micro world. So it's nano world, it's concerned that it starts from the 10 power minus 9 meters. So the DNA width is 2 nanometers, and this quantum dot is it's 5 nanometers, and carbon nanotube is a 1.3 nanometers, and buckyball is a 1 nanometer. This is 1 nanometer. These are that nano world. So it comes from that macro world, then it's micro world, then it's nano world. Then it's after that it goes on pico world and femto world. That's on research is going on. So that the same a comparison of nano size, that's how that starts from that macro world. There's millimeters, micrometers, and nanometers. Then it goes to picometers, then femtometers. So now we are discussing on this nanometers. So these are the structures. There's a different size for various size from the human being to 1. And humans laptop, it's about 1 meter. The human being is 1 meters. Then butterfly, it's about 1 mm. And biological cell and nucleus cell is 1 micron meters. Similarly, it go for that. It's the width of DNA. It's 1 nanometers. It's ranging from 1 kilometer, then meter, then millimeter, then micrometer, then comes to the nanometers. So that's how the range has been developed from kilometer to nanometer. The figure is describing. What is the reason to miniature? Why should we go for small? What is the benefit of if you are doing in small things? It's make it small. So that the benefit of making small or miniature is we can get that it makes itself should be faster. So that due to that small size is small, and so that it makes faster. If it goes that faster, that its speed has been increased, so that we can reach and finish it work as early as possible. Then lighter, it should be once that miniature it's applying the nano technology, it becomes a lighter, so that if it is become lighter, the weight has been reduced, then efficiency has been enhanced. So that ultimately that we can have the higher efficiencies, and ultimately that it's becomes small and lighter, the cost also it's becomes cheaper. Then and resources also it's limited. So we can accommodate in small spaces due to that miniature or size being the size small. So we can accommodate in the very small spaces. So you require only less spaces. So it's energy efficient. So it's provide it's high efficiency, high energy. So we can easy to handle due to that small size and small miniature. So it's unique properties for small scales. So and disposable and avoid contamination is possible due to that miniature or make it small size. So the size of nano molecules and this atomic molecules, that's water molecules, it's 3 atoms, contains 3 atoms, and protein molecules having the thousands of atoms, and DNA molecules of millions of atoms, and nano wires and carbon tubes having the millions of atoms. These are the different structures of this atomic molecules. So this water molecule, protein molecule, and molecule of DNA. This is a carbon nanotube. nano shells, nano wires, nano beads, nano chips, nano cones, nano crystals, nano filters, nano containers, nano dots, quantum dots. These are the different shape and size of the nano materials. So the nanostructures is contained that we have various structures, various dimensional structures, which is ranges of 1 to 100 nanometers. So two-dimensional structures such as thin film, planar quantum wells, superlattices are these are the two-dimensional structures. One-dimensional structures, it's the nano wires, quantum wires, nano rods, nano tubes. These are the one-dimensional structures. Zero example that bulk nanocrystal films and nano composites. This figure shows that nano thin film and multi-wall carbon nanotubes. So nano shell, basically nano shell is it's a nanoparticle composed of silica core surrounded by the cold coating. It's basically it's a 100 nanotubes is rolled into the graphite sheet is rolled into the tube, which having the 1.3 nanometers. The buckyball, this is a ball saucer ball shape. A molecule, saucer ball shaped molecules made of 60 carbon atoms. The respective figures shown in that right side: nano shell, quantum dot, and carbon nanotube. And it's initial basic steps of tip preparations. Then it's converted into the next steps called the workpiece preparations. So what type of workpiece required, what type of your objective, what type of your problems according to the workpiece has been prepared. Then it's controlled by the atomic level. The molecules has been controlled or manipulated. That means called the position control. Then it's once the position control, it's become the final product, which is useful for the applications in industry as well as nano manufacturing is basically a process which is helps to produce new nanomaterials, which can be powders or fluids or solids. But it should be nanoscale 1 to 100 nanometers. This is basically a nano manufacturing. Basically, nano manufacturing is a process of producing new nanomaterials, which can be powders or fluids or solids, which should be 1 to 100 nanometer scale. The bulk material, the bigger size material, the huge size material is subsequently refined into small scale material, which possesses the 1 to 100 nanometers. That is called top-down approach. From the top to you are coming to the bottom. It's a macro to nano. So bulk material is subsequently refined down into scale nanometers. It has been refined into small materials, so it becomes a nanostructures. For bottom approach, the atoms, various individual atoms and molecules, it's built clusters, then make it the nanostructures. This is a basic concept of basic approaches of nano manufacturing. So top-down fabrication, refine into powder, then it's nanoparticles. Similarly, for bottom-up approach, that start with the individual atoms and molecules and build upwards and make the nanostructure at nanoscale. See that atoms at individual atoms and molecules, it makes the clusters, then it becomes the nanoparticles. So it's how the top-down approach has been formed. Basically, the processes are synthesized or constructed by removing the existing material from the larger entities. That is the top-down approach. There is a synthesis, there is a various types of synthesis, whether it is mechanical synthesis or chemical synthesis. We can go for any type of synthesis and construct it, removing the existing material from the larger entities. So the figure shows the bulk material into the nanomaterials. The nano objects are constructed entities without the atomic level control. That is the more important in top-down approach. And it's every product begins with the bulk material process, subsequently refined down into sort of molecular recognitions. Then it's become the nanostructures. The fabrication of device structures, it's processed through the systematic assembly of atoms and molecules or other basic units of matters. These are the approach of bottom-up approach. Basically, the assembling of nanomaterials atom by atom molecule, it's called the self-assembly. This approach is much cheaper things become much larger. Examples of molecule assembly are quick base pairing and nanolithography is one of the methods for nanolithography for the bottom-up approach we can discuss in further. So, in the synthesis approach of nanomaterials, we have the different methods. For top-down approach, for mechanical grinding methods, that using the mechanical grinding approach, which can be helps to larger scale materials can be grinded into nanoscale. These are one of the mechanical grinding method. Another is the lithography techniques, which can be the chips, teeny chips can be relatively large structures, which can be reduced into small nanoscales. These are lithography techniques. And bottom-up constraint that we have two different methods. One is the self-assembly, other one is the position assembly. In the self-assembly, the nanostructures are self-assembled without any external manipulations. But position assembly, we can manipulate the atom and molecule by using the external support. So, other different methods for synthesis of techniques, that gas phase methods, which is water evaporation and condensation methods, and chemical vapor deposition method, and laser ablation method. These are the gas phase methods for nanomaterial synthesis. Another is the chemical methods such as that precipitations, microemulsion synthesis, sol gel synthesis, spray drying and spray pyrolysis, and thermal decomposition. These are the methods which is for chemical methods which is for developing the nanomaterials by using synthesis. So, mechanical deformations, already we have that mechanical alloying, that chemomechanical alloying, that and severe mechanical transformation, that's a mechanical grinding methods. These are that another method for synthesis techniques. So, what is the difference between bottom-up approach and top-down approach? Here it's bottom-up approach, we are starting from quantum to nano, there it's bulk to nano, that means the macro to nano. It can be bottom approach, it's found from the nature, but here cannot be found from the natures. But here the bottom approach is a high precision, but comparatively in top down is a low precision accuracies. So that bottom up no wastage materials, but in top down materials we are reducing the materials from large size to the small size. Ultimately the wastage material takes place. So the nano fabrication techniques such as that for top down approach we have the different techniques: electron beam lithography, dip pen nanolithography, nano imprint lithography, and UV imprint and UUV lithography, laser ablation and etching lithography. This figure shows that the process of lithography, there is a narrow line and narrow trench, it becomes a modified substrate, become the by using the nanolithography we can get the nanostructures and nanomaterials. So that we have the different others: electron beam lithography, X-ray lithography, focused ion beam lithography, block copolymer lithography, nano imprint lithography, dip pen lithography, interference lithography, contact lithography, UUV. These are the techniques which is used for the nano fabrication by top-down approach. Bottom-up approach, already we discussed the chemical synthesis, self-assembly and position assembly. These are the three methods for bottom-up approach. So, top-down lithography, this is one of the methods for top-down lithography techniques. This film deposited in this deposited film substrate, in the film deposition, the first figure. Then it's go for the photoresist application by using the photoresist techniques and applying the photoresist. Show then it's more lights exposure in the takes place on the film, so that edging will takes place. So optical exposure will passing through the film, and etching takes place. Its etching may be the aqueous or plasma etching takes place. Finally, the material has been removed. That finally we can get the nano shape materials. So similarly for bottom up approach, that position control will allow the atoms to be placed precisely without parts pumping into each other. So without pumping, without acting the external force, that position has been atomic position has been controlled. Its manipulation takes place. So by using the drugless robotic arm. So another is a robotic arm to control placement of atoms by the SOET platform, which is stiffer and simpler than Drexler ophotic arm. These are the two methods which is used for that position control by using the bottom-up approach. So then how the nano material has been developed? So before developing any nano materials or nano composites materials, we should know the basics, fundamental of understanding, the fundamental of the nano materials. This what type of material we have to develop. The material, what are the applications where we can use these materials. So accordingly, we have to select the methods and and ingredients, the chemicals and other things we can select accordingly. So it's what type of application, mainly based on the application we have to develop the materials. So we can basically define the problems and clearly mention the type of application of the product. So accordingly, we have to develop the new nano materials. Then it's go for the modeling and simulation. So whether it is withstand the force or pressure or whatever that it's subject to the applications. So that can be animated by using that modeling and simulation. That can be checked and evaluated. Then after that, it's go for the characterization and experimentations. After that, fabricated that it can be characterized and experimented. We can get that final results and that it's synthesis and integrated. Then we can get the final objective after whether it can go for the testing of mechanical, optical, electrical properties. So whether the result has been within the limit, within the limit or not. Show whether that after that characterization that size of nanomaterials have been within the nanoscale or not. This has to verify. Learners, we have 2 minutes small break. Then we'll continue after that break.
Creative, if you can write well, and if you can visualize, mass communication is the correct career option for you. I am going to talk about postgraduate diploma in journalism and mass communication, which is also the first year of MA program in journalism and mass communication. So any learner who has done a postgraduate diploma in journalism and mass communication is eligible to take admission straight away into the second year of our master's program in journalism and mass communication. Duration to complete this program is minimum 1 year, and because we have this inherent flexibility in distance education system, you can take up to 3 years to complete this program. The minimum eligibility criteria for taking admission in this program is bachelor's in any discipline. To give you a glimpse of what are the various components of this program, we begin with telling you what mass communication is, what are the various areas, various branches of mass communication. Then we go on to tell you about the various reporting techniques and beats of reporting, followed by media ethics, the principles, the codes of conduct that you must follow, and we also focus on the writing skills and editing skills for print media. Now this program comprises of 8 courses of 4 credits each. 25% of the entire program is practical based. So we have 6 theory courses and 2 practical courses. This program is so designed so that it will be able to make you more employable in the market. So it helps you build a career in print media, in radio, television, new media, as well as the allied subjects of mass communication, which could be media marketing, advertising, public relations and corporate communications, event management. This can also help you become an entrepreneur in areas like photography or having your own production house and so on. So I hope that you will be excited to join this program. and we will be waiting to welcome you here in IGNOU.
Learners, welcome back. So, nano-composite materials. What is nano-composite materials? The two or more materials are made distinctly and dissimilar components and mixed and synthesized at characterized at nanometer scale, which is 100 to 100 nanometers. Such a materials produce new materials which possess much superior properties than any other materials. Its average grain size would be less than 100 nanometers. That means that scale 1 to 100 nanometer range. Basically, the two or more materials are made, it may be a distinct and dissimilar components. It is not necessary to the same material or same component. It's a dissimilar and distinct materials and distinct components, and mixed, it properly mixed and synthesized by various techniques and characterized by the various instruments at nanometer scale, which is 1 to 100 nanometers. Such a new materials, once after they synthesize, they produce a new material which possess superior properties. If you go for the testing of the new material, the various testings, it provides the superior properties than any other conventional materials. So that normally that its average grain size should be the less than 100 nanometers. So this figure shows that nanoparticle and matrix, it should be dissimilar and distinct material and dissimilar components. This produce the composites, nano-composites materials. So there are various methods to produce the nanomaterials. There is a sol gel process, inert gas concentration, mechanical grinding, mechanical alloying or high energy ball milling, plasma synthesis, and electro depositions. So these are another methods to produce the nano powders. So rapid expansion of supercritical fluids. These are the three methods which is available for producing the nano powders. Rapid expansion of supercritical fluids, particle from gas saturated solutions, depressurization of expanded liquid organic solutions. These are the three methods which is helps to produce the nano powder, which powder contains the 1 to 100 nanometer. These are the one of the mechanical grinding methods to produce the new nano materials. This is one sample. We are discussing the one sample of producing the new nano materials by using the mechanical grinding techniques. She will take initially the cetylpyridinium bromide plus water and clay particles as per the norms prescribed by the volume. The clay particles and stir the mixture. We have that cetylpyridinium bromide and water and clay particles, and they have being the mixer. That clay particles stir with the mixture with rigorously for 24 hours at room temperatures. This should be in the mechanical grinding and stir it for 24 hours at room temperatures. Then separate the clay particles after stirring by using the mechanical grinding. So separate, make the dry into the clay particles and keep it dry for 48 hours. So that we will get that pure dry clay particles. From add that clay particles with the polymer resin, which provides the bonding properties. Add the purified acrylic as a monomer. Add polymerization initiator, the benzyl peroxide. So we can mixing the all three monomer and polymerization initiator and resin, polymer resin with the clay particles. Then again it's mixed and stirred vigorously. Then it go for heating up to 80 degrees centigrade about 1 hour. After that again it's cool up to 40 degrees centigrade. Add the hydrogen hydrate as a hardener. Then it's poured into cavity and allowed for the curing for 1 month duration. Then it's go for testing as per ASTM standards as is prescribed by the ASTM. So these are the one of the mechanical grinding methods to produce the nanocomposites materials. Then after that poured into the mold cavity for that new material has been formed. The material as the shape of material has been as specified by the ASTM. Then it's go for various mechanical testing, chemical testing, temperature, thermal testings. So we can compare the results of this nanocomposites material with the conventional material. Then what is the properties difference will take place. Ultimately, that nanocomposite materials provide the superior properties than conventional materials. So what are the things we can measure in the new developed materials? So we have the two different aspects. One is the composition and structure and properties. Three aspects we can measure. Normally we can go for the properties, concentrate on the properties. Compositions is atomic space, concentration, diffusion, segregations. These are deals with the nanoscience and structures, crystallinity, strain, defects and surface roughness. These are the measurable structures. These composition and structures is based on the nanoscience, and properties mainly it's go for the nanotechnology. So here are the various properties we have to for measure or check or verify. So such as the magnetic, electric, optical, mechanical and thermal. So mainly that the magnetic is concerned that accessibility and magnetoresistance. For an electrical and optical concerned that Seebeck coefficient, carrier density and electron slates, and band gap, dielectric constant and conductivity. So mechanical concern that we can have the different properties such as we can test yield, tensile strength, hardness and various its failures, strength and stiffness, modulus of elasticity. Thermal concerns the conductivity and specific heat. These are the properties we can measure of the developing the new materials. So there are the various tools and equipments for use synthesis and characterization of new materials such as scanning electron microscope, transmission electron microscope, atomic force microscope and scanning transmission electron microscope, reflection electron microscope, scanning tunneling microscope, X-ray diffraction and UV spectroscopy. These are the tools which is used for the synthesis and characterization of the new nano materials. These are scanning electron microscopy, how that material has been tested or the scanning has takes place by using the scanning electron microscopy. So here it is instead of light, the scanning electron microscope uses the electrons. So the conventional microscope is using the lights, here it is using the electrons to see the 3D image of the object. Object concerns the materials. So that a determine which is used for that scanning electron microscope operations, it's determine the particle size and distribution. Whether that particle size is which is within the nanoscale, it's 1 to 100 nanometer or not. That it has been to be verified. So examine the fracture surface. In case if it is any fracture takes place in the materials or any cavity takes place, so that kind of failures can be detected by using the scanning electron microscopes. So E-gun emits the high energy electron beams. The electronic gun emits the high electrons beam. It's passing through the anode. Then it's passing through the magnetic lens. Then it's scattered in the electron deflector. Then passed in the specimen. So the surface topography has been recorded in the TV scanner by using the secondary electron detector. The image has been displayed in the TV scanner by using this scanning electron microscope. So the resolution should be the 5 to 100 nanometers. These are the working of scanning electron microscopy, how that electrons used to produce the image of the object. These are the outcome of the scanning electron microscope image, how that nano composites material has been displayed and detected by using the scanning electron microscope, which the material structures has been within the 1 to 100 nanometer scale or not, that can be detected. This is another method, this is atomic force microscopy. Here it's a laser using for detecting the images. There it is a small silicon tip, 100 nanometers diameters, to make the images sample materials provide along the surface. That we have the object, laser, mirror, and detector, and cantilever beam, and tip, and the sample. The tip is moving along the sample, the laser beam passing on the sample through the mirror. So detector has been detect the images. The image has been verified whether it is within the 1 to 100 nanometer scale or not. So the adjust of the height of probe to keep the force sample the constant. That can be the force can be keep it the constant. The imaging, measuring, and manipulation of the object has been takes place. It's creating the 3D objects, so that the resolution has been detected in the detector. It should be the 0.1 nanometers, and lateral resolution, and vertical resolution is a 0.02 nanometers. These are how that atomic microscopy takes place in the surface. This is the image outcome of the atomic force microscope. It shows that it's 8 nanometers carbon by the carbon nanowires. How that this atomic force microscope working and detecting the image in the detectors. So transmission electron microscope. This is another microscope. Here it is a high energy electron beam to produce probe material with thickness is less than 100 nanometers. Is a high energy electron beam are using. Some electrons are absorbed or bounded of the object. Some pass through the object and make magnified images. Some electrons are absorbed, some electrons are passing through the object. So digital camera records the images, which show the image shows in the bottom of the image of the object. The scanning tunneling microscope, this is one of the conventional method that's using nano-sized probe to scan object and materials, using tunneling techniques to detect the surface and create a map of surface. The rate of electrons and tunnel from the probe to surface related to distance between the probe and surface. This is another method to detect the image of the object. So next, the thermal investigations. What are the thermal aspects, parameters we can investigate or detect? So the differential scanning calorimetry, which helps to determine the phase transition temperature of the materials as well as the glass transition temperature of the materials. Also, we can study the melting point of the material and crystallization of and curing temperature of the materials. This we can study it by using the differential scanning calorimetry. And TGDTA and TTG, the thermogravimetric and differential thermal analysis and differential thermal gravimetry analysis, which can help to study the temperature difference between the temperature and difference and mass difference of the materials. Also study the changes in polymer decomposition temperature between the two different samples. Also to study the thickness of polymer layer surrounding by the nanoparticles. These are the two different thermal investigation method. And structural investigation concerns that we have the different structural testing methods. Here we have found that superior mechanical properties compared to the simple composite materials. This is one of the tensile testing machines. So we can determine that various mechanical and structural characterization can be by tensile testing and dynamic mechanical testing and nano indentation. These are the various methods for detecting the structural analysis. So that go for the testing, structural testing, that the results of that nano materials, the property should be that superior than any other conventional materials. So what are the characterization required for the nanomaterials? Normally, the nanomaterials should be less weight. Then only that efficiency has been increased. And at the same time, the weight should be reduced. At the same time, it should be very strong and hard. For example, that aircraft structures. The aircraft, we have to reduce the weight of the aircraft. At the same time, it should be very strong and hard. Once the weight reduced, that efficiency has been enhanced, the speed has been increased. Similarly, for the increase in operating temperatures. So, by using the nanomaterials, we can operating temperature has been increased. Also, ductile properties at high temperatures. So, by using the nanomaterials, we can use the high temperature applications wherever it's required in high temperatures. For example, nuclear power plants, thermal power plants, there it's high, working on high temperatures, we can use the nanomaterials. So ultimately, it's once that weight is reduced, so automatically the efficiency of the vehicle or aircraft it has been enhanced. So also it's give the better resistance, wear resistance, as well as provide the thermal and dimensional stability. So it should be resist the chemical corrosion, antimicrobial activities. It's totally resist the all chemical corrosion. So then automatically it should be pollution free. So then medical concern that it's different advantages by using nanomaterials. For example, for treatment of cancer and heart disease, its illness has been end. Universal immunity, the AIDS and flu that has been purified, and plastic surgery and body sculpturing, the change of appearance possible by using the nanomaterials. By using the nanomaterial, the aging process has been reduced. So, childbirth has been painless by using the nanotechnology. So, immortality, the research is on progress on COVID-19 and other diseases. And industrial and social advantages are there is a self-assembling computer goods. So that by using the self-assembling computer goods concept, that production of computer goods has been increased. So computer billion times faster and million times smaller. So automatic pollution cleanup takes place. So manufacturing cost has been reduced. So the product has been cost also is reduced. So customer has to purchase the product in the affordable price. So molecular food synthesis takes place, which can help for global starvation, for air travel and space travel, and provide the education in superior form in various aspects, and reintroduction of extinct animals and plants. For example, reintroduction of dinosaur and rare plants which has been destroyed. So that can be reintroduction is possible based on nanotechnology, and terraforming Earth and other planets has been possible. It's inexpensive on space travel. The space travel cost has been reduced. It should be the inexpensive. One has to travel in space in the economical cost, affordable price. So there are various general applications that we know that for nanomaterials by using the aircraft, space, defense, and marine, food, agriculture, chemical, automobile, electrical, electronics, medical, biomedical, optical, structural, recreation, and cosmetics that can be discussed in detail one by one. So the basic requirement of nanomaterials, it should be lightweight, high strength, high toughness, resist to corrosions, easy repairability, and it can be reusability, less maintenance, a long durable. It should be low cost. So aircraft and concern that the aircraft nanomaterial has been used in the various structures of aircraft, such as airframe structures, aero engine parts, aircraft electrocommunication systems. And space concern that can be used for nanosensor, nanorobots, laser sails, nano rovers, space suits, and space foods. In marine and automobile concern that in ship we are having that nanomaterials used in vessels, hull, shipbuilding, ship surface coating, smart ships. In automobile concern that body and chassis, engine, window and wipers, wheels and tires, and automotive cooling. These are the applications of nanomaterials. And the another important application of nanomaterial is the nano coating. What's the purpose of nano coating? The self-cleaning, it's clean itself. The dust particle it won't absorb in the wall or the surface. It's optical clarity. It provides the optical clarity, improve the smoothness, resist the heat as well as the corrosions. So this figure shows that nano coating object, how water drops takes place in the dirt particles. So the dirt particle goes down. It won't absorb in the surface. Normally, in the figure shows that the Pune International Airport, that recently their surface completely they coated by the nano coating. So the benefit of the nano coating of the surface wall that it won't absorb the dust particles. Automatically, it's by self cleaning immediately. So no need to clean or wash the surface or the wall. It's self cleaning takes place. So these are the important applications of the nano coating. And defense concerned that it's various applications in defense for a nano sensor, which can be helps to detect the biological agents as well as weapon. So biological agents wherever it's hidden, that can be determined, that can be identified, and weapons can be identified. And that is used in the radar, the unmanned air vehicles, GPS systems, helmets, jackets and uniform, durable and bulletproof. It's protected from high temperature as well as very low temperature and impacts on chemicals and bombs, etc. As well as its huge application in food and agriculture. It's preserve food without refrigerations, that possible by using the nanotechnology without refrigerations, and protection of food from bacteria and disease. So it's help to contamination from the bacteria and disease, avoid the disease also, and it can make it lighter weight and safe foods. So it make it lighter and it can be helpful for the space travel. As an agriculture concerns, it's by using the nanotechnology we can enhance the productivity of the agriculture through the precision farming. So identify and control the cure of crop diseases. The various crop plant disease can be controlled by using the by nanotechnology, and pesticides and fertilizers also for manufacturing through the by using nanotechnology for crop growth and plant growth. And test and monitor condition of soil. That soil can be tested and monitored by using the nanotechnology. So agriculture, this is another major problem for agriculture waste destroying. That has been helps, nanotechnology has been helps to for reduce the agriculture waste, keep the environment clean and neat. So medicine, already we discussed that various applications in AIDS and cancer treatment, bone treatment, drug delivery, appetite control, drug development, medical tools, diagnostic tests and imaging. So IT sector, we know that it's lot of applications by using the nanotechnology in IT sectors. It can be smaller and faster and more energy efficient. So it's carbon nanotubes replace a silicon transistor. Earlier we can use a conventional silicon transistor. When that carbon nanotubes has introduced, that it can be immediately replaced. And nano rods in the display techniques, due to less consumption in electricity as well as less heat emission, the nano rods are used in display techniques. And microprocessor reduced to greater extent. Size of microprocessor has been reduced by using the nanotechnology. The nano dots, quantum computing and medical imaging, printing and spin coating by using the nano dots. So energy, it's various energy applications in solar, generating steam from sunlight, nano solar steam device, and high efficiency light bulbs, nano plasmonic device, increasing the electricity generation by windmills, nano windmill blade. These are the application in energy sectors. And generate electricity from waste heat by using the nano tube sheets, storing hydrogen for fuel cell power cars by using the nano graphene layers, reducing power loss and friction reduce the energy consumption by using the carbon nanotubes. So ultimately, that in energy sector, the improving the efficiency and reduce the cost of fuel and solar cells. So thin film applications, solid fuel cells, thin film solid electrolytes and electrodes has with having high conductance, so that the fuel cells having the large storing capacity. The thin film transistors for liquid crystal displays requires high mobility and flexible substrates. Is a gas sensing applications. So thin layer in electronic devices also used. So nano wires helps in a lot of various application in electronics and sensor detectors. For example, for that field effect transistors, thermoelectric materials, LED, light emitting diodes, detectors, sensors, nano lasers, and superlattice nanowires in application of repairing superlattices. These are the nanowire applications. And earlier that for aluminum used for in that system, for then later on it's changed to copper. Now we can using the carbon nanotubes. It's replaced in the systems. So crime, it's the crime prediction also one of the important applications by using the nanotechnology. So that narcotics examinations, in the narcotic examination we can it helps a lot, and fingerprint analysis of suspected crimes, and DNA testings and sequencing analysis, and forensic investigations, drug identifications, document examination, and trace evidence analysis, and CCTV and ultra and unmanned air vehicle security systems, and detect and diffuse explosives also is possible by using nanotechnology. So consumer goods, we can have that foods and beverage, appliance and textiles. For foods concerned, that it's packaging, advanced packaging materials and sensors, and lab chips for quality testings, and textiles concern stain-proof, waterproof, wrinkle-proof textiles, and household, sports and cosmetic items. It gives a better appearance and good aesthetics, and self-cleaning and scratch-free products. So we have a lot of applications for nanotechnology. At the same time, some drawback also in the nanotechnology. So every technology having their own advantages, applications. At the same time, they have some disadvantages, some failures, some unexpected problems also. For example, that some pitfalls of nanotechnologies is ultra-fine particles can catalyze chemical reactions in the body. The chemical reactions in the body can possible by using the ultra-fine particles. So carbon nanotubes can has an infection in the lungs. So blood and brain barrier can take place. Cell can be damaged. So oil and diamond becomes worthless by using the nanotechnology. So atomic weapon is more accessible and destructive. So it may destroy for its damage that threaten the world, and nano liquid destructive, and psychological fear and fear of grey goo. The nano liquid destructive concern that the nano liquid bomb, when that toothpaste or oil tube, there we can nano liquid bomb. That nano liquid has been stored in the pressurized in the toothpaste or the nano liquid bomb, that can be pressed and the nano liquid bomb will be explosive. So these are also possible. These are some drawbacks. So that learners, we have come to the end of that topic. So now it's nanotechnology. It's a nanocomposite material. It's improve the properties. It's provide the superior properties. It's provide the high energy surfaces, and increase the confidence, and reduction in the test program cost, and improve the confidence in design factors. So it's facilitate nanomaterial development, increase the flexibility in design of new products and manufacturing cost. So learners, we have a lot of employment opportunities in the nanotechnology. It's different sectors. So we can go through on nanotechnology in various aspects. It gives a lot of changes, economic development in the country. Thanks for your passion listening.